Today we'll talk about the PostgreSQL and artificial intelligence. So it's a little bit of different topic about the pure databases and that. So it's a mix of artificial intelligence and Postgres. Specifically, we are talking about database, but specifically PostgreSQL. So my name is Ibrar Ahmed. So I have been in PostgreSQL since 15 years and software industry since it's been 23, 24 years now. So I have multiple books on PostgreSQL. So that's PostgreSQL and artificial intelligence. So the main agenda is here. We will talk about what is the artificial intelligence. So we will briefly discuss about the artificial intelligence, and then we will discuss about how we can use that uh, artificial intelligence in PostgreSQL and PostgreSQL in artificial intelligence. So it's a both way. So in artificial intelligence, we can use a database, but in database, we can also use an AI. So we will talk about the both aspect of that, and then uh, little demonstrations of how we can use database in artificial intelligence. So artificial intelligence. So what is an artificial intelligence? It's a mimic of conjective function that human associate with the human mind, such as learning and problem solving. So when we think about a baby, what is he doing? He's just start learning. He doesn't know anything. He start learning, and they start solving the problem by using his knowledge. So we mimic the exactly the same thing artificial intelligence. We try to teach our computer, and computer will learn from the data, and then it starts solving the problems. So that's artificial intelligence. It's 100%. They try to mimic the human mind. So human mind try to learn and then solve the problem. So similar to that, the computer can do that the same thing. But it's artificial intelligence. It's not a real intelligence. So but it can be used for that. So artificial the Albert Einstein, the artificial intelligence is no match for the natural stupidity. A machine with the strong AI is able to think and act just like a human. It is able to learn from experience. So the human also learn from their experience. What they have learned, what they have observed, everything. That's the human brain works. It start learning things from that, and they can start solving the problem out of that. So I think the development of a full artificial intelligence could spell the end of the human race. That's Stephen Hawking. The one who becomes the leader in this sphere will be the ruler of the world. So type of artificial intelligence. So we have three type of artificial intelligence. So first one is the A and I. So artificial narrow intelligence. So when we are talking about the narrow intelligence, then when we teach a computer a specific task, and then the computer start doing that task, that's the only one task he is doing. So that's called a narrow intelligence. So computer is not doing everything for you. We just try to teach a computer a single task, and that computer start doing that task perfectly. So that's called a narrow intelligence. Then we have a artificial general intelligence. So when we are talking about the narrow intelligence, it's behind the man. So when we are talking about the general intelligence, we try to match the computer intelligence with the human intelligence. That computer can do whatever a human can do. So whenever we have not achieved that goal, we have achieved the narrow intelligence. We teach computer to do something, and computer can do that. For the general intelligence, the scientists are working on that to achieve that. The computer can do whatever a human can do. So that's a general intelligence. So third one, third one is the artificial super intelligence. What is a super intelligence? It's a super intelligence is when you're talking about a computer, and computer can do much more than the human. So when we are talking about the super intelligence, that means a computer. When you compare a computer and a human mind, a computer can do much more than the human. That's called a super intelligence. So it's a question how computer can do much more than the human. The problem is that the human can learn, read, and start solving the problem, but the human cannot remember the whole huge amount of data. He can read that if you have records of billions of records. A human cannot memorize that billions of records, but computer can do that. Computer has that capability, can have the capability of human, and they also have the information stored in that, which cannot a human cannot store in their brain. So in that case, computer can work much better than the human. So it has a learning capacity, it has a problem solving capacity, and it has one more thing, to accommodate a huge amount of data. And that's the edge of computer over the human mind. So we have a three: narrow intelligence, which is a single task, and we have a general intelligence, which is mimic the almost the same human brain. And the third one is a super intelligence, which is beyond this human mind, just because it can hold a huge amount of data in that. So the previous was the type of artificial intelligence, but we have a subfield of artificial intelligence. If we're just talking about the artificial intelligence, so it's nothing. It's just a word that is artificial and the intelligence. But when we are talking about the real world, so how we can achieve the artificial intelligence, that's one, a machine learning, then the deep learning, a neural network, a conjective computing, the NLP, and the computer vision. So these all are the subfield of artificial intelligence. So it depends what kind of a problem you have. You have to choose one of these technology or subfield of artificial intelligence. So machine learning. So it's like a machine is learning some kind of a book, some kind of a data, some kind of a thing. Then when it learns, so we will give them the problem to solve that problem. So how we can achieve that? So machine learning have a three types actually. The one is a supervised learning, and one other is unsupervised learning, and third one is reinforcement learning. So what is the supervised learning? Supervised learning, you have a data, a test data, and you have the result of that data. So what that data tells you, you have the label, the data and the label. And when you start training your model using that data, and you have also have the label, the output of that, and you compare your training data with the resulting data, and you train your model according to that. So when you're doing that, something like that, if we train our model that if suppose we have a vehicle, we can say that it's a vehicle or it's a scooter, two-wheeler. So we can see that the one property of that, it's a four-wheel, it's a four-door, it's something like the windscreen, something like these are the feature of one thing. And it's a, so the target is, the label is, it's a car, it's a four-wheeler. And you have two wheels, doesn't have a windscreen, something like that, and a scooter. We have the data and the output of that too, that what that data tells you. So we try to teach our model that extract that information and compare that with the resulting value, and then it start learning. When the model start learning that and learn from that, so whenever it gets the data of four-wheel, windscreen, other than that, not so it will say it is a car, it's a four-wheeler. So we have data and the label, resulting value of that. So we train our model on that. So how we use that? We use that in a classification, in a regression. So in classification, we can classify that this is a car, this is a bike. We can classify that. Whenever you put that in a bike, so if you say, oh, it is a bike, we just give the characteristics, it said it's a bike. We give the characteristics of car, it said, oh, it's a car. So we can use that in a classification and a regression. And what is the unsupervised learning? In unsupervised learning, you have only the characteristics of that. You don't have the resulting value of what it is. So we have a characteristics and we don't have the value. So what is the benefit of that? The benefit is that it's used for association. It's used for the clustering. What is the association? When you go to the math, so you have seen that whenever you buy a bread, you can see that where the bread is there, there is also eggs are there. There, butter is there. Why is that? It's because of this association. They have the model that whenever a customer buy a bread, he usually also buy eggs there also. He usually buy a butter there. So usually they place that things in a one bucket, then to enhance their sale and facilitate the customer. So from this model, that association that you put the data that one customer buy bread, one customer buy bread, so you just l- train your model whenever he buy bread, he buy eggs, he buy butter, he buy something like that. So your model is trained. So you just put all the information in all the things in one area. Similar like that, he was sweeping the cleaning stuff. So they have that. So it's called association. And even the clustering, you can also cluster that this is a chair, this is a bed. So it just segregate that information. So it's a different thing, it's a different thing. So using the characteristics, it clustered the data. It's called unsupervised learning. So third one is a reinforcement learning. Whenever we are talking about the reinforcement learning, it's it's something like that, a hit and trial. It's used in robotics. What is the hit and trial? So whenever robot is in the room, if he start going to the right side, he doesn't know it has a door or not. It start going to the right side. He see he touched that and see that this is the wall. He come back. He go to the left side. He touch that. This is a wall. He go back there and he see, oh, there is a door. So he come back on the first place. Now the robot knows that whenever I go 4 steps to the right, it is a wall. When 4 steps on the left, it is a wall. But I go to the 20 steps in front of me, it is a door. So next time, whenever he wants to go to cross the door, he will never go to the left or right. He just go to the door. So it's called a reinforcement learning. He just roaming around the road in the room, and he finds where is the window, where is the door, where is the switch. So after some time, how much time he spent in the room, he knows everything about the room. So that's called a reinforcement learning. So how this machine learning works? So you have a data. So you divide your data in two parts. One a training data and a test data. So that data, you prepare your data, you train your model based on that information, and then you test your data. And if his data is correct, that's okay. If your data is not correct, then improve it. So it's continuous process to improve your data because you have the features, you have the result. So just compare that our result and the actual result same or not. If it's not same, there is a delta on that, and acceptable, then okay. If it's not acceptable, then retrain it. So we start training that. So how much data you have, it will better be trained. So we have one topic is the machine learning, and then the deep learning. So initially we just put the data into the uh, computer, and we put the features, and then we extract the information. What if you don't know the features of that too? You want to cluster that, and you don't need the feature. That's the four-wheeler, something like that. You don't know anything about it. You need to extract that feature too. Then here the come, because in a human you don't know that information. You just observe that. So now we are actually mimicking the human brain. So human brain actually in the cell that is called the neurons or something like that. So they just named similar like that. It's a neuron and a neural network. So it's like that. So neural network. So we have input layer. We have an input layer. We put that input layer, the input values of that, and then we have hidden layers. We are not talking about in the detail how these neurons work and how many hidden layers you must have. It's a complete big topic here. Then you have an output. So you can have that output. If that output is correct, That's okay. If it's not correct, it's go back. Usually it's called a back propagation. So go back and readjust the value. So find out this output A is output B. So I will give you the example with the next slide. So when we have a network of neural networks, so we have a multiple layers on that network. So that's called the deep learning. It's extension. You can say that the extended term of neural network. So we have. So how you can use that? So in this picture, we have not. You can see that we have a lot of pictures out there. Some are black and white, colored. They have a different hair color, something. So we have this all pictures. So we want to identify which picture is what. So we have to segregate the pictures. So we have not provided that it has two eyes. We have not provided that it has no something like. We have not provided any information. We just put that information, and you can see that in the first neural network, you can see that it start extracting the eyebrows or something like that from that, and then on the next layer, it start recognizing the eyes or something like that, and then you can see the face. It just start recognizing the face, and ultimately, the final he will just say that it has many pictures and these are the pictures. So this information can be segregated using the deep learning process. So we think about what is the difference between the deep learning and the machine learning. In machine learning, actually, we discussed that in machine learning we provide the features. We even in the supervised learning, in unsupervised learning, we provide the feature and in some cases provide the result or not, but it extracts that information. But in deep learning, we are not extracting the feature. The extracting feature is part of the deep learning process. So in a first machine learning, you can see the input. Input is a car and feature extraction. A human should extract the feature of this input value, that it has a four wheel, it has a windscreen, something like that. He has to input that information. Then it will say it is a car or not a car. All right. And in a deep learning, we just give the input and it start recognizing it's a car or not. So how we do that as a deep learning? We will put the input of car and we will put that input as a motorbike. So two things. So he will just categorize that this is a separate thing and this is a separate thing. He doesn't know it's a car or motorbike, but it said that it's two different things. It's not the same thing because of that feature extraction. It will start extracting a feature. First feature is extract something like that, and then it recognizes that this is a different and then it's different. And we label it that this is a car and this is a bike. So we have very brief knowledge of what artificial intelligence and machine learning and deep learning is. So we now time to go to database. So here is an example of you can see that. So does any integer have non-leading zero? You can say any zero on that. So if you see that 31903 has a zero, 82392 doesn't have a zero. So there are medical model who can do that. Even you can just string search and you can use that. But we will do that using the machine learning neural network. We will do that using that because we can do that other way. Because as a simple example, I don't want to give a very complex example where a mathematical model cannot work there. But here, mathematical model easily can work on that. But for example, we are taking this an example. So we have to train our model that on that he will detect that this number has a zero or not. We will give a random number to that, and he has to predict that its number has a zero or not. So PostgreSQL has a different support for the different languages. So Postgres also have a support for the Perl, it's called a PL Perl. We have PL Python, PL Java. So I used here a Perl. So you can also use the Python. So Python is much easier than that. But thanks for the Bruce. Actually, he was here, but he's my friend, so he's not here. So I took his example from Perl. So thanks for him. Oh, sorry. So it's available, Momjan, main, writing, all the examples are there. You can find that, you can download it, and you can try it on your computer. So tensor is actually, you can call it as a vector. It can use to store the data. It's just a name of that. We are storing the data on that. So now we will input our data. We have data and huge data, like not huge, so we can say the 100 numbers and random numbers, 100 random numbers, and we have the result that this number has a 0 or not. We have that number too. So we will give 80%. Usually we divide that into 80% or the 70%. We give the 80% data to our model, to train our model. Then 20 to 30% to test that our model is correct or not correct. In 30 to 70%, we know that this number has 0 or not. We already know that. We feed that into the computer. But for the rest of the 20 or 30%, we only provide the number, not that it has a 0 or not. So it was a comparison that when we give the 30%, it will predict that correctly or not. So here is the code. I am not going in detail of the Perl code here. So how you run that, you can always go and try that on your laptop. So it will take much more than that actually. So here I created a table of training set. So training set, we will insert a data of 70% or 80% of our data from the actual data to the training set. And then we created some random integer values. So just for the input to insert that. So here you can see that a training set. We have a very small training set here. If you see that, so you see that we have a number 28762748. It doesn't have a false. So we have the value and we have the result. So both, you can see that we have the value and we have the result. The second number has a 0. It's true. And the third, fourth. So we have the number, we have the result of that too. Both the things we have, because it's a training set. When we generate a data with a testing set has this values only and doesn't have the training output. It has only testing has, training has the both the column, and the testing doesn't have that column, second one. It has only this column. So now we start training over. So we will generate some weight for that. So I'm not going to tell you. You can just go and copy and run that. So I will show you the result. Okay. Now we will test 100. We have other example now. Okay. We will test 100 now. So we already trained. We have provided that data. I have showed you that this is the data and this resulting value, that it has 0 or not. It has a unit. We have that information, and we trained our model using that code I supplied to you. You can go and download that and train your model. So your model is trained. So I want to test that the 100, give the input 100, it has a 0 or not. And you can see that the accuracy of that 0.22193.865. So we are now testing. Its accuracy is only 22%. It has chance that 100 has a 0, only 0.22, that 22%. Why? And it says 0.77 or 77% chance it doesn't have a 0. So why is that? The problem is that we have provided very low training data. We have provided on 100 values, or 20 values. So our model is not well trained. If you provide the millions of values, then this accuracy will start increasing. So if you provide a very less value, your accuracy. So you can have a delta that if your accuracy is 90%, then your model is trained. Or you can say it's 80%, as a 99%, then your model is trained. But now our model is not properly trained. It's only a 22% accuracy is there. So just because we have not supplied sufficient data to train our model. So it's similar like if a child, you see that it's a 2 years or 3 years, it doesn't have that information. He doesn't have that amount of data in his mind. So he cannot predict that if you take that children out of this mountain and you say this is a mountain or not. If he has never seen that mountain in his life, he can't say what it is a mountain. But he's born in the mountain areas. He's always recognized that it is a mountain. So that's how much data you provide to your data model to train it. So that's the accuracy you will get, the maximum. So let's test the 101. So here the accuracy is 0.11, it's 11%. It's also decreased. You can see that it has a less zero here. So its accuracy more decreased then. So it's again the problem of the training of the model. So here we can see that even you can see that this doesn't have a zero. It said it's a 68% chances that there is a zero in that because the model is not properly trained. You have to train that to have a much more accuracy on that. So let's say that with the we can final table expressions are that we test with the thousands of values, right? And the final accuracy is 15%. It's not good because we are not testing that one by one value. One value maybe can have a 80%, other value can have a 2% accuracy. But you have a training data, you have the testing data. On whole testing data, you have to average that how much accuracy you get on the testing data. You train your model on training data, and on testing, you average that how accuracy for each element, and then average it out, and you can see that how much accuracy you get. And you can set the threshold. We will use this model if that model achieves the 90%, 80%, or 70%, whatever your desired task is. So I have used a database demonstration here with the AI, but why to use a database? Well, you have a data somewhere, you can use that in an AI. So why to use? So machine learning requires a lot of data. I gave you the example that if you don't have any data, you don't get the proper trained model, right? So machine learning requires a lot of data, and the most of the data are in your database. You're not storing your data into the CVS file. 90%, even I have seen, even you can say the 99%, the libraries using the CS file, CSV file or XML file or that, they are not using the database. Why? What the people are doing, they have the database, they have the data in their database. What they are doing, they are exporting that in the CSV file, run a machine learning or AR algorithm on that, and then go back to that. So why? Why not using the database for that? That's the main purpose of this presentation. So don't export and import your data from CSV file because your library supports the CSV file. So you have to do that. So I have given you the example that you can use AI and machine learning, artificial intelligence, NLP, everything within your database. Use your data where it is. Don't try to export that in other formats. Why not machine learning where data is? It's in database. Similar thing. So try to have your algorithm within your database and use your data what is in the database. Don't export it. So that's the one point that you have the data. So what are the major advantages of that? What are the major advantages of that? I told you there is a 2 point. I have discussed the one point. One point is that you add support to AI using the database. Now you are using uh, database support into AI because AI need data and you provide the database to that. But there is other ways too that within the database you need AI. Database need AI. So I will discuss the second. Use the previous activity as a training data. So now AI using the data within the database. So you have a previous activity, like you have a user logging or something like that, and you want to something like you have phone calls. You have a phone calls data, and they have some malicious activities going on the phone. So your model is trained what kind of an activities had done that phone number. So your model is trained for the data. It immediately can alarm that this can be a malicious activity. So you don't have to export your data to the CSV file or run your model, train your model and come back. So it's continuously learning from that. So have seamless access to all your current data. Seamless, like you have insert one data, it will put into the machine learning. So maybe you can set the threshold when data is 1 million, then again put that into machine learning. So you don't have to export and import that, export the data, import the model. So you don't have to do that. Take immediate action on AI. Like if you are exporting and importing that, you can't take an immediate action. Like commit a transaction only if likely a non-fraudulent. So you have a transaction, and your machine learning algorithm say that if it doesn't look like a fraudulent activity, commit that. If your uh, model say that it's a fraudulent activity, don't commit it. You can set an alarm on that. So you can continuously use that and take an immediate action without the interruption of the user. You don't require a human mind to detect that it's a malicious activity or not. Machine learning. So you have put the mind into your database that it can automatically predict that. AI can benefit from database transaction, concurrency, backup, so it can use that. Other benefits include complex data types, full text search, GIS, indexing. So these can be used. Like if you have a CSV file and you are running a machine learning algorithm on a CSV file, you have only a data. But when you are running a machine learning algorithm within the database, so you have a full-fledged application, database server, that which has a full text search, which has a GIS information, which can have an indexing. So you can the AI algorithm can utilize these kind of activities in that. Postgres can do GPU-based computation inside the database, so you can also utilize that into your machine learning algorithm. So other than that, general artificial intelligence use by database, user applications, performance adjustment. You can do a performance adjustment by by using your trained model. Then you have an optimizer plan. Then you can have index creation and destruction. So this is the second aspect. First aspect, I told you that you use database from for your AI application. Now you are using AI for your database. It's other way around. So how? Like you are for index creation and destruction. You can have an algorithm that it predicts that after some time your table will be slow. Just create an index. It will predict that create an index after 3 months. It can predict that this index is never been is not using that index quite frequently. Delete that. So now database getting the aid from AI. So database settings, like you have that you have setting the database, and you just ask that what database setting I need. Usually people do that using the hardware capabilities. And if you have a 100 GB of RAM, just the shared buffer in PostgreSQL is 40 GB or 30 GB. It is just using the information human is using that hardware is that capable. Just use that setting for that. But what if It depends on your data workload too. So if you have an AI algorithm, it start learning that you need more shared memory. You need more shared memory to have a better result, a better query response. Just increase that. Maybe it can generate an alarm. You need a more bigger hardware for that. Your data, your optimization for the database is getting slowed down. To just have another hardware for that. So AI can predict that. Similar, I said told you that as a resource usage. It can also, like if you have a database, like, and you can set an sometime it's happened your database is shut down because there is not enough space available for that. Oh, it's critical. So if you have an AI algorithm and it start predicting that your hard disk will be full after 1 year, 3 months, and 2 days, it will predict that from your previous data. So you have to be alarmed that I have to buy another hard disk. I have to add more hard disk into the system after 1 year because after 1 year, 2 months, 3 days, it will be over. But naturally, people think that this month 10 GB, next month 20 GB, the third month it will be 30 GB. No, it depends on data. Maybe it's a holiday, so it never been used. Maybe it's like a COVID situation. People have predicted that their database will be full after 3 months. No, it's never been used because nobody came to the restaurant which is filling the data. So this kind of aspect always taken care in the AI. AI predict that if you see that the one you are using 1 GB daily, so normal human mind think, oh, 7 days, 7 GB. No, it predicts that Saturday, Sunday is holiday. No data generation is there. Maybe 1 MB. So it will taking care of that. It taking care of the holidays. He start learning that, oh, okay, 1st of July is holiday in US. Okay, there will be no data. So it will predict. He will see that because in previous date he has seen that on 1st July there will be no data. He has a 10 years of data and see that on 1st July there is no data, no data, no data. That means on next 1st July there will be no data. So model will train with the previous data. Now it's predicting that your hard disk is full after that information. So this is the database activity, and even malicious activity on your database. You see that this IP address usually come from that area. This IP address is coming from north of Europe or something like that, Central Europe. Usually these IP address. So model is trained, and you see that this IP address is coming from the America. It's not possible. It's a malicious activity. Maybe they are spoofing that. They are changing the IP address, something like that. So the model is trained. You are not manually inputting that IP address. This IP address is for Europe. You are not manually inputting that. It's extracting that feature from that. That this information is coming from the Europe. This IP address is coming from the Europe all the time, and this time it's coming from the US. Similar, like it's not IP address even anything. You see that 99% chance. You see that 99% chances are there. You are Google using the Google. You see that when you are using the Google, and you have Tor or something like that, which is hiding your IP address. Sometimes it says you are a bot because first you use your computer and search it, and it's coming from the France and then Germany. I said, how is not possible that you are switching the time that frequently? So usually it just put that you are a bot. Just click that you are not a bot. So the algorithm is running that this IP address are coming from there. This is there. The search usually this search is coming from that area. So they just segregate that. And resource exhaustion. Definitely, I already told that the resource exhaustion, that it can predict that when this resource will be exhausted. The memory, something like that, the hard disk, the CPU. So that's it.